The electrical code generally prohibits installing multiple 4 kilovolt branch circuits within a single conduit. This restriction primarily stems from safety concerns related to high voltage systems. When dealing with voltages as high as 4 kilovolts, the potential for insulation breakdown, arcing faults, and even explosions significantly increases. Containing multiple high voltage circuits within a confined space like a conduit exacerbates these risks. Firstly, the heat generated by multiple current-carrying conductors operating at 4 kilovolts can quickly exceed the conduit's thermal capacity. Overheating can degrade the insulation surrounding the conductors, leading to short circuits and ground faults. The higher the voltage, the greater the stress on the insulation. Secondly, the close proximity of multiple high-voltage circuits increases the risk of inductive coupling. This phenomenon occurs when the magnetic field produced by one conductor induces a voltage in a nearby conductor. In high-voltage systems, inductive coupling can create dangerously high voltages in adjacent circuits, potentially causing equipment malfunction or electric shock hazards. Thirdly, the physical manipulation of high-voltage conductors within a conduit poses a considerable risk to electricians. Working with energized circuits at these voltage levels requires specialized training and equipment. The limited space within a conduit makes it difficult to safely install, splice, or terminate conductors, increasing the likelihood of accidental contact. Furthermore, in the event of a fault, the arc flash hazard associated with high-voltage systems can be extremely severe. An arc flash is a sudden release of electrical energy that produces intense heat, light, and pressure. The confined space of a conduit can amplify the effects of an arc flash, posing a significant threat to personnel in the vicinity. For these reasons, electrical codes typically mandate strict separation requirements for high-voltage circuits. This may involve using separate conduits for each circuit, or employing barriers or other physical means to prevent interaction between conductors. The specific requirements vary depending on the voltage level, the type of wiring method used, and the occupancy of the building. It is crucial to consult the relevant electrical codes and standards, such as the National Electrical Code (NEC) in the United States, to determine the applicable rules for your specific installation. These codes provide detailed guidelines for conductor spacing, insulation requirements, and grounding practices to ensure the safe and reliable operation of high-voltage systems. Always consult with a qualified electrical engineer or inspector before undertaking any work on high-voltage circuits. They can provide expert guidance on code compliance and safety best practices. Ignoring these regulations can lead to serious consequences, including property damage, injury, or even death. Consider also the ampacity derating factors that would apply if multiple circuits were permitted. NEC tables like 310.15b3 address ampacity adjustment factors for more than 3 current-carrying conductors in a raceway or cable. With high-voltage circuits, the heat generated is a significant concern, and derating factors would quickly reduce the allowable current, potentially making the installation impractical. Furthermore, the impedance of the circuit would be affected by the close proximity of the conductors, potentially leading to voltage drop issues, especially over longer distances. The NEC provides guidelines on calculating voltage drop and recommends limiting it to a certain percentage of the supply voltage. With high voltage circuits, maintaining proper voltage levels is critical for the reliable operation of equipment. Additionally, consider the potential for harmonic currents in high voltage systems. Harmonic currents are non-sinusoidal currents that can cause overheating of conductors and equipment, as well as interference with other electrical systems. The presence of multiple circuits in the same conduit can exacerbate the effects of harmonic currents. Filtering or other mitigation techniques may be necessary to address harmonic distortion. Proper grounding is also essential for high-voltage systems. The grounding system provides a low-impedance path for fault currents to return to the source, helping to protect personnel and equipment from electrical shock hazards. The NEC specifies detailed requirements for grounding electrode systems and equipment grounding conductors. It is crucial to ensure that the grounding system is properly designed and installed to meet the requirements of the code. In addition to the NEC, other standards may apply to high-voltage installations depending on the specific application. For example, the Institute of Electrical and Electronics Engineers (IEE) publishes standards for power systems, including high-voltage equipment and wiring. These standards provide detailed technical guidance on the design, installation, and operation of high-voltage systems. Moreover, local codes and regulations may impose additional requirements beyond those specified in the NEC or other national standards. It is important to check with a local electrical inspector to determine the applicable requirements for your area. When working with high-voltage systems, it is essential to use appropriate personal protective equipment (PPE). This may include insulated gloves, sleeves, and masks, as well as arc-rated clothing. Proper PPE can help to protect against electric shock, arc flash, and other hazards. Regular inspection and maintenance of high-voltage equipment are also crucial for ensuring safety and reliability. This includes checking for signs of insulation damage, loose connections, and other potential problems. Any issues should be addressed promptly to prevent equipment failure or electrical hazards. Remember that working with high-voltage systems is inherently dangerous and should only be performed by qualified personnel. Always follow safe work practices and use appropriate safety equipment. If you are not qualified to work on high-voltage systems, consult with a licensed electrician or electrical engineer. They can provide expert assistance and ensure that the work is performed safely and in compliance with all applicable codes and regulations. In summary, the general rule is that multiple 4 kV branch circuits should not be installed in the same conduit due to safety concerns related to insulation breakdown, arcing faults, inductive coupling, and arc flash hazards. Always consult the NEC and other applicable standards to determine the specific requirements for your installation. Seek guidance from qualified professionals and prioritize safety when working with high-voltage systems.